Let's today discussing in this video finest models of coarse aggregate and fine aggregate by using sieve analysis. Scene one by one. Don't get any delay. Let's start the video. First one is the finest models of coarse aggregate and fine aggregate by using sieve analysis. It is an operation of a dividing sample of aggregate into fraction. The particle size distribution of aggregate is determined by sieve analysis. Is termed as the grading of aggregate. That means by using sieve analysis to determine the particle size of the aggregates or coarse aggregate or fine aggregate. Next one, it is conducted to determine the finest modulus of a coarse aggregate and fine aggregate materials. Next one is by the sieve operation can be performed manually and mechanical means. Manual and mechanical. The sieve of a 80 mm to 150 microns are arranged above other with the largest opening at the top. That means the largest opening at the top of the sieve and smallest opening at the below the sieve. And after sieving 15 minutes, the material retained on each sieve is to be weighted. Then we should calculate the value of finest modulus sieve size. See here, types of sieves, set of sieves. 4.75 mm below is the fine aggregate, 4.75 above is the coarse aggregate, 2.36, 1.18, 600 microns, 300 microns, 150 microns. These are all the fine aggregates. 10 mm, 20 mm, 40 mm, 80 mm. These are the coarse aggregates. Next one is the fineness modulus is the ratio of sum of the cumulative percentage to 100. That means fineness modulus equal to sum of cumulative percentage of retained by 100. The following limits may be taken. The fine sand 2.2 2.6, medium sand 2.6 to 2.9, coarse sand 2.9 to 3.2. Lies the limits between fine sand and coarse sand. See here. And coarse aggregate fineness modulus value 5.5 to 8. Coarse aggregate. Coarse aggregate 5.5 to 8. Next one is the node. The sand, the fineness modulus of sand having 3.2 less than, more than, it is not suitable for concreting in construction mixing. Find out the problem and the fineness modulus of the fine aggregate. Given sample 100 grams. Fineness modulus. We draw the table in the first one is the sieve size and mass of retained in grams, percentage of mass retained and cumulative percentage of mass retained. First one is the set of sieves writing in, because of the question is given fine aggregator. So because 4.7 below sieves are taking 4.75 and 2.6, 1.118 mm, 600 microns, 300 microns, 150 microns. Next one is the mass of retained is question. In the question is given 0, 100, 220, 250, 230, 200. Next one is the percentage of mass of retained. How to calculate percentage of mass of retained? See here. First, mass of percentage equal to formula weight of retained by weight of retained by total weight of retained, weight of retained by retained by retained by retained by here total weight of weight of retained into 100 into 100. See here. First one is for example, 0, weight of retained is 0 by total weight. Total weight is given 100 grams, sorry, 1000 grams. into 100. That means 0 by something 0. Similarly, 100 by 1000 into 100. That means we got we get a two zeros, two zeros, 10 and 10. When we get to 10. Similarly, do the all values here getting 10. Similarly, 22, 25, 23, 20. Cumulative percentage of mass retained. See writing here similarly, and 0 plus 10, 10, 10 plus 12, 22, 32, 32 plus 25, 57, 57 plus 23, 80, 80 plus 20, 100. The percent total cumulative equal to 279. Formula equal to finance sum of cumulative percent retained by 100. 279 by 100 equal to 2.79. The finest modulus of a sand 2.7 point range is a medium sand. Medium sand. Similarly, coarse aggregate. Find out the finest modulus of a coarse aggregate for a given sample 15 kg. Similarly, sieve sizes writing here and mass of retained and percentage of mass retained. So cumulative percentage mass retained. First mass of retained in the question is given and the percentage of mass retained calculating how to similar formula similarly mass of weight of retained 0 by 15 15 the question is given total mass of retained into 100 0 by something 0 0 similarly 0 by something 0 and 6 by 15 into 100 6 by 15 into 100 100 100 we get a 40 we get a 40. Similarly 5 by 15 similarly do the same procedure all values and next one 0 plus adding 0 0 0 plus adding 40 0 plus 40 40 40 plus 33.33 is 73.33 plus 73 point plus 26.66 even 100 100 plus 0 0 100 plus 0 100 100 plus 0 100. Similarly adding all values similarly in similarly similarly adding all values sum of cumulative equal to 713.33. Finest modulus formula sum of cumulative percentage by 100. Sum of cumulative equals 713.33 by 100 equal to 7.133 means this is a coarse aggregate. I hope you clearly understand to everyone. Like this video and subscribe to my channel. Thank you very much.